Our next speaker of the morning is Dr. Art Schafsma, Professor Emeritus from the University of Guelph. Art is a cash crop farmer, author, and speaker who oversaw research, teaching, extension, and business development at the Ridgetown campus of the University of Guelph for over 30 years. His research program has focused on pest management strategies for corn, soybeans, and wheat. The main types of his research include risk management for seed treatment use in corn and soybeans, farm-to-fork management of mycotoxins in wheat and corn, management of invasive and key insect pests of corn, soybean, wheat, and insect resistance management for transgenic corn. He is an international leader in development application techniques to optimize the effectiveness of fungicides for Fusarium head blight control in wheat and corn, and was involved in the development of Doncast model for deoxynivalenol in wheat. Art is here to discuss effective control strategies for Fusarium head blight control.
Thanks.
Thank you. Yeah, thank you.
So I got to point something out on this first slide here. It says Professor Emeritus. You know what that means? Every day is a Saturday. And so I'm retired. And I do farm a bit. And this year we have wheat. And this is the first snow, real snow, that I've seen all year. Everything has changed dramatically. We have had only about 4 or 5 days of frost in February where it froze overnight. And my wheat is green, and we're scared silly because we're going to have this March weather, and that's the worst month. I thought I wasn't going to have this again. Sometimes when you speak, you get this thing called dry mouth, and that's no fun at all. So yeah, it's a little scary right now, and I understand that you had who was here on Wednesday? How many were here Wednesday? About half of you. So for those that were here Wednesday, I have one more comment to tell you. You might not know what I meant by a tailgate sample when you do sampling for Fusarium or mycotoxins in the grain. That's simply in the stream as you unload the truck or the wagon. For the whole stream from start to finish, you have a little dipper cup and a 5-gallon pail, and you just go like this and throw it in the pail. And that's the gold standard. That gives you the best answer. It involves some work and time, but that gives you the most reliable answer to use when you test for the mycotoxins. So to carry on here, I've been asked to talk about strategies to manage the problem you might have. I first have to acknowledge a colleague. We worked directly together. He was my research associate way back when. So we were in the same program together, David Hooker. And now he's a professor at the University of Agronomy, and he really knows this stuff and was very helpful over the years. And so some of the stuff we did together that I'm going to show you. And this other person, Rushi Jia, she's from China, amazing young woman, and she's now an agronomy extension specialist with Alberta Grains. And so that's quite an accomplishment for her, and she did some really interesting work that I want to share with you as well. So I stole this from her defense presentation when she did her master's. And just a little bit about the cycle, some key points here. So I was driving around, or on the way here, we stayed at Charlottetown, and I noticed that there was a lot of plowed fields, which we don't see in Ontario much at all. We are more into conservation tillage, but I understand how it works on the potato side of things and the scab and so on. But one advantage you have over us is I know that corn is becoming more important on the island, and I understand it's all plowed. And so that helps you because you bury the crop residue. That's where we have our biggest problem, is the corn residue. That's the biggest source of Fusarium spores that we have to deal with. So in any given year in our area, we have enough spores flying around that tillage doesn't help us that much. Whereas here, you might have an advantage. I've never studied that, and I don't know, but I'm guessing that is so. So we have crop residue as being the start of the infection down here. And then from the residue, we get these sexual spores called ascospores. And those are the most important. Sometimes we get non-sexual spores called conidia coming as a cycle throughout the year. But really what happens is, as the weather is favorable on that crop residue, you get another flush of sexual spores from that residue, and that provides infection for both the wheat earlier in the season and also for the corn later in the season. So it's basically functionally a single cycle disease, whereas biologically it's a multiple cycle disease. These are the little asci, little bottles that show up as black spots on the crop residue, and it produces these little ascospores that fly around in the air. And I know a fellow that did some research on the Empire State Building, right on top, and he collected air samples, and he was able to find Fusarium spores up there. So they're all over the place. They move around easily, so it's not necessarily, the spores are not necessarily a limiting factor. And then we get that Fusarium head blight, and the thing that bothers us are these tombstones or Fusarium damaged kernels, and they're quite loaded with deoxynivalenol or DON when you harvest it. So Dave put this really nice visual together a long time ago, and we keep using it because it tells a nice story. So each of these pipes that go into the main pipe kind of represents roughly the amount of contribution those different factors make to the disease. So this was based on data that we collected on farm right after a huge epidemic in 1996. We had almost 100 fields that we went on to collect data, and we asked the growers all kinds of questions about tillage and fertilizer and variety and planting date, you name it, we asked it. And then David, he's an expert on statistics, and he ran it through the grinder and came out with what is important. And these pipes kind of show you relatively what's the most important. So tillage contributes a little bit. Crop rotation also a little bit, so we don't recommend planting wheat or cereals after corn, because corn is a very important reservoir of residues, of Fusarium, as I mentioned earlier. Genetics come out very strongly. And the most important factor is weather. So if you have a whole bunch of the wrong weather at the right time, you're going to get nailed no matter what you do, in a sense. All right, and so obviously that seems to be what happened this year for you folks. And then after the fact, so this was added in later, we learned that fungicide application, along with genetics, helped an awful lot as well. So that data set and subsequent data from several years and some from different countries helped us to develop this forecasting system called DawnCast. And what it allows you to do is enter field-specific agronomy data, such as planting date, such as fertility and crop rotation and so on, and previous crops. And then you can put in the heading date, so it's a dynamic, you can go into it every day or anytime you want, as many times as you want, and you can update this information. And then you can add, and the company that runs it now is Weather Innovations Incorporated, or WIN, and it also adds in forecasted weather. So you can, as time gets closer to the time of spraying, you can see what your relative risk is. The problem with some of this is that heading date is not uniform in the field. And we found that it can vary from, 4 or 5 days in some years, a window, as long as 1.5, 2 weeks. It all depends on the year. And so you have to make a decision when to spray relative to how many heads are emerged. And you'll want to wait till most of the heads at least have emerged, and some of them, or a bunch of them, have flowered. And I'll explain that in a minute. So what I want to show you here, this is a chart of the number of varieties that have different characteristics. And so the highly susceptible varieties in 1999 ruled the roost. And there were, and as time went on, we learned, and we cooperated together. We learned in Ontario that you really don't want to have highly susceptible varieties. And so we basically kicked those out really fast. And what we have now is a system that has a highly susceptible check in it every time. And we have inoculated plots at 2 or 3 locations in Ontario. And we rank all of the new varieties that become registered for their susceptibility to Fusarium and their ability to produce DON. And so here's the progress. We now have more moderately susceptible ones and more moderately resistant ones. Now, the challenge has been that as you breed resistance into the varieties, we couldn't break that yield drag until just now. So within the last 2 or 3 years, we now have varieties that are both moderately resistant and competitively high yielding. So I have to look at my hand and write it down. I have on my farm 25R74. So that's the first time that I've had a more resistant variety. And if you spray and have this variety, then you're not likely, even in a really bad year, not likely to have a huge problem. You might have somewhat of a problem, but not a huge one. We also now have a bunch of fungicides that you can use. And so Folacure is the weak beginner. We had to desperately beg for it right after 1996, and we worked closely with Manitoba, and we went to Ottawa. I was involved with that, and we pounded on the table, we need this, and so I think for 7 years or 8 years in a row, we had an emergency registration every spring we had to go back, or winter we had to go back to Ottawa and ask for a registration. But now we have Proline, and then Procero, which I think Procero is probably the better choice. Caramba, I always thought was a good choice as well. It's an old compound that's been around for a long time, but relatively new to wheat in Canada. I thought it was great until I used it about 8 years ago, and it works good for Fusarium, but he sprayed at about 11 o'clock in full sun, and I lost 20% yield because of burn. And that wasn't the active ingredient, it was the carrier, the solvent that burned the wheat, but I haven't used it since. All right. A new one that we like, it's not cheap, is Miravis Ace. It has adepidine in it, which is a new class of chemistry. And the reason why we're excited about it is you can apply it a little bit earlier. It has to be in head, but it has some flexibility for application. And it is a new active ingredient, and so we can help to manage the development of resistance. So you want to, rotate your chemistry from one year to the next, so we avoid that resistance. There is resistance already reported to the triazoles, which include the first 4 bunch in the U.S., so it's not something that you should ignore. And the other thing that Miravis ACE did to us when we did a lot of work to research this. I borrowed this slide, but we saw exactly the same thing. We get a staggering effect, which can give you, a 3 to 5% bump in yield. And so you can see that here, and I can verify that does happen. But you have to realize that it's a relatively expensive product. Timing of the fungicide is important. You want to make sure that most of your heads are in flower. Almost all of them have emerged, so they're exposed. And only the Miravis ACE can go a little bit earlier after heads are emerged. And again, I want to remind you about that challenge in flowering time, because you got to pick a date somewhere, and I can't help you with that. You do have to just kind of make an educated guess when you're out there. And the other thing, and so I don't know, hopefully everybody recognizes this as a wheat head in flower. Now be aware, some varieties don't extrude their anthers, and so you might not see the flowers that well, okay? You'll have to go in and look for them, but most varieties that I know of do show their anthers when it's time. So the important thing, and I don't want to steal any of Tom's thunder, he's going to talk about spraying next, but we did some cool stuff a long time ago already. Again, this was with Dave Hooker. This was a lot of fun because we had all kinds of things going on, and we had to work like the dickens, and it was a long day, but we did it. And so we had the sprayer rodeo. And some of you are going to, I heard that you had trouble getting into the field to spray because it was so wet. Is that right? So I thought I'd say a little bit about aerial application. Now, what kind of aerial spraying do you have in the forest industry? Is it fixed wing or is it helicopter or both? Zero? No, I'm talking about across the strait in New Brunswick. What's that? Mostly fixed wing? Okay. We do mostly helicopter because it does a little better job. Okay, and yeah. So I just want to give you that, put it out there. Maybe you don't have access to it, but I just wanted to show you. So what we did is we put out these cool little water-sensitive papers, and we made them into artificial heads. So we had cylinders out there, so we could then cut them into sections and analyze them all separately, front, back, left, right, to see what the coverage was. And we also loaded the sprayer with some copper sulfate. If we had to do it with a fungicide, then it would be hazardous to us running around, and it would cost us a fortune for analysis. But a copper sulfate test is relatively inexpensive. So that was our reasoning. And then we had these papers laid out in the field before whatever came. Some were ground sprayers, different kinds, different nozzles, all kinds of things. And then some were aircraft and so on. And we had these papers out there, and so we could look at swath patterns, and we could look at replication here, and so on. So what this does is shows you the relative comparison of different nozzles. And we were a little disappointed with the aircraft because it didn't look like we were getting a lot of coverage, all right? But the particle size or the droplet size is really small, so you had a whole bunch of little tiny droplets, and they didn't show up that well on the paper. And then when we looked at the actual copper on these different papers, back, left, front, right, okay, it was relatively even, okay, and it was a decent amount. So at first we weren't real excited about aerial, but ground application gets a whole lot more material on the heads. There's a little bit of problem, but the best situation was something we had with a forward and backward nozzle. And what we had was, I can't remember, it was like a flat fan, and there were angles about like this, and then we had to put a yoke on 2 nozzles, and it was a very expensive solution. So nobody wanted to do it, right? And some did it, but basically they kept trying with twin jet nozzles and so on. So just to show you a couple of things about what happens with air, this is a swath pattern, and you can see that, you know, we're getting a lot of variability in the swath pattern with a fixed wing. All right, and there's a lot of, what do you call it? What do you call that, the swirl, the foil? The vortices, yeah, okay. And, but you're still getting a relatively nice amount on the heads all around, but still with some variability when you look at the copper concentration. With helicopter, you can see the swath on the bottom there. The swath is more uniform all the way around. So we still recommend ground over air, but in the Dakotas, they've done a lot of work with aerial application, and it's better than not doing it by quite a bit, but it's not as good as ground. And my friend Helmut Spieser, who was involved with all of this as well, he's an engineer at our campus, he came up with a clever idea. Now don't just ignore the drop pipes. It's there so that we can put all the nozzles at the same height, because we're comparing different nozzles. So you don't need a drop, okay? Basically what it is an alternating flood jet. And so you have one pointing forward, one pointing backward. And the coolest thing about this is you can really go, you know, up to 10, 12 kilometers an hour. And the faster you go, the better it is, until it gets scary. But you get pretty good coverage with that, or really good coverage. So this is what everybody's doing now in Ontario. Another thing that my buddies do, so I only have 100 acres, so I don't know if that's big or small, but for us, it's really small. And so I don't have a lot of say. I can't afford equipment, so I have friends. And they're really good friends because they treat me well, and they farm thousands of acres. And so one thing they do now, pretty much every year now, is they go as early as they can so that the grain can get through the combine without getting mushed. So you have good quality grain, that's when they'll go. And so it's roughly 22% they'll start. And then they have a dryer, all right, and they dry it. And then they've had the best luck with that. And so we have seen that the longer you leave the grain in the field and you continue to get weather, that dawn level continues to climb. And you can have a lot of nice looking kernels and have significant dawn in it that you didn't think would be there. And I've proven that. So I had a field once, I knew it was going to rain, so I sampled the field on a Friday. It got harvested on a Tuesday, and I sampled it again, and we had double the dawn in the sample. All right, so it does go up. So drying it quickly and immediate. So I don't know how many dryers you have around here, but that's something that's worth looking at. Now, back to Rushi. She did a real cool project. We wanted to see how much we have brought in Ontario the management of Dawn since 1996. So this is like a 20-year period, okay? So we took a snapshot then, and we took a snapshot kind of now, and we wanted to see how bad 96 would have been had we had the tools that we have today. So that was her study. So we had some old high varieties that were really bad, and then we had some that were susceptible. So we got rid of all the really bad ones over time. This one's still pretty bad, 25R40. It was very popular, high yielding, but it was a little dangerous. And then we have 25W31, which is a white wheat that is moderately susceptible. And then we had a 25R46 that are moderate resistant, but these had a bit of a yield drag. And so that was 2016. Now we're in 2024, and I got 25R74, all right, which is high yielding and also moderately resistant. But we didn't have that one at the time in the study. And then we added the fungicide. So we took the best fungicide that we thought, the Miravis ACE and untreated. And then we know that the nitrogen rates have been climbing over the years, so we wanted to see how that impacted things. So we did this over 2 years. And then we really challenged it. So we inoculated it, we misted it, and so we kept this damp, and we had a lot of Fusarium in there. So this is the result. The T-DON means the total DON. I recall when I talked to you on Wednesday that you have different metabolites of DON, and they're all important. So this shows you all of them together. And if you had these older cultivars, so we got it all the way up to almost 20 parts per million, which is a nasty thing. And then just with the variety, we brought it down about 50%, okay, with the best varieties. And then with the fungicide, we dropped it another almost 50%. So we're going, you know, in total, 70%, 67 to 70% if you put the two together. All right, and so what we did, and then the yield also made a difference. And with the, I can't remember now, now I'm trying to think here, yield. Oh, this is the nitrogen. So the nitrogen with and without fungicide. So there's a synergy between the nitrogen and the fungicide. So that's worth looking into. And you've probably learned that from the yen program here and from elsewhere. And the fungicide effect. Now you can see that, whoops, that's not what I wanted to do. How do I go back? There we go. What you can see is that there's a yield drag here based on the variety, okay, which we don't have anymore. So anyway, she took all of these, and then the conclusions that she had was that we had a lot of improvements, and we had a nitrogen rate bump, and the fungicide was also effective. Okay? I forgot. So then the other cool thing she did, which was a little more involved, is she took that data and she plugged it into our Dawncast, and she went back to the fields. She could identify 83 fields that were usable from 1996. And then we reran the weather. The weather was archived, and so we could go back to that. And then she put in what varieties there were and all that kind of stuff. And she put it into a black box and a lot of modeling. And that's way above our heads for today. But the end result is she wanted to see what the impacts were. So The nitrogen has increased the revenue. The Fusarium head blight management, the moderate resistant cultivar increased revenue by about 20%, and the fungicide increased revenue by about 30%, let's say, and putting the two together, she had an increase in revenue of about 50 to 60%. So, yeah, it's been quite an achievement. So what she did is she plugged this into numbers of values, and so in 1996, the winter wheat total value was about $115 million. And then if you did all the right things in 1996, and there was no Fusarium head blight epidemic, you would have had quite a yield bump, and no Fusarium head blight discounts, and we would have had a total value of $239 million. And so that works out to about $125, $130 million. Now, back then, we hadn't done any of this. We didn't know any of this. And I guessed that the yield loss, and I published that, but it was a guess. I guessed 100 million. So we weren't too far off. It was pretty cool. But anyway, there we have it. So there is room for improvement. We can still grow, all right? And I'll tell you that we've had about 3 or 4 really bad years in the last 15 years, 10 years, and we have not had the same effect that we had in 96. So we pretty much, in wheat, have it under wraps. So we can still get a bit of a problem, but through blending and moving stuff around, we can manage it, all right? And the key to that for us was the varieties and the fungicides and the application technology. So the end result here, just want to summarize, with the toolbox that you have an advantage right now with the tillage, plowing. The corn down is a good thing from that standpoint, but I see a lot of red water on the way here. So that's, you know, for me, that's a scary thing. Crop rotation is really important. So wheat or grains after corn will be more of a challenge for you than it was for us. Fungicide is really important. The timing is really important, okay? And the covering the head all around as best you can is really important. And there was a question that Tom got the other day about water volume. And people asking, can we put on lots more water? And at first, in the early days when we were looking at this, it scared me, because any time you lengthen the wetness period on the head, you're going to increase the risk of infection, especially around that critical time. But then I did a study for other reasons, and we didn't have water to put on because we were too far away from our water source. So we had access to a big John Deere sprayer overhead, and I just loaded it up with water, and we went, you know, a bunch of times over the field every day to keep what we thought would keep it wet. But with that amount of water, which is way, way, way more than you would ever do with a spray, I didn't have a significant amount of Fusarium catching. So I'm a lot less worried about that. And the last tool, just before you get it in the bin, is try to get that crop harvested early and dry so that you don't get it moving on. So we have, and that's what I have to say. We have lots of time, I think, for some questions. And I hope you have lots of good questions. Yes?
Talk about applications of the fungicide. So should we allow the dew come off in the morning before we spray?
No, you don't need to. No. I worry more about it being too hot and too dry. Yeah. I was his third field that day, and the other two didn't get dinged, and I got dinged, and it's the same product, so anyway. Any other questions? Yes?
You kind of touched on it briefly in your presentation, of how you went in later. I had a sample of wheat that was, so I took it and had it tested, and this sample didn't look very good at all, okay? I could just tell it was full of disease. I had it tested locally, and it was 6 parts per million of Don, okay?
Mm-hmm.
They took a cup out of it and tested it. I took that sample back home with me, and I spread it out at the kitchen table, and me and the kids spent an hour picking through every kernel that was diseased, even small ones and everything else. I will say the first 10 minutes was kind of fun, but the next 50, that was
I've done it too, lots of times. And then I hire students to do it.
So I had this sample that just looked beautifully. Like if you had seen that, you would have said, I want that product. I was excited. Jumped in the truck, went back out and had it tested. Fully expecting to be 0, 1, whatever. Come back at 5.3 parts per million.
Yeah.
I dropped it 0.7 parts per million by taking out anything that I thought was bad. Why did it only drop that low?
Because there was a continuing infection on sound kernels. So that's what I told you earlier. Remember I had that field that, and so the field didn't look too bad. It had a little bit of Fusarium in it, and it didn't look any different when I went back after a bunch of days, and the dawn had doubled, okay? And so you had a year where it just the rain kept coming, right? It kept being wet. And so that illustrates very nicely how you want to make sure you get that grain off as soon as you can, because it will increase and increase a lot. So that damaged kernel was already there.
But not showing up like the tombstone kernel, obviously.
Yep, and no, yeah, so you took all the damaged ones, all right, but they were already there. What has changed is the nice-looking ones also got infected and didn't show.
Would that ever happen in my sample bag for the 2 weeks after harvest, or was it in the field? Do you think?
Either one. So if you, what kind of bag was it?
Yeah, like a fairly big Ziploc bag.
Okay, so it's a plastic bag, the grain's in the bag. If you have that in a week, it's not all the way dry. So it could have been that too.
Well, could have been the field too.
Could have been the field too. Never, sorry, but never take a sample into a plastic bag and hold it for any length of time if you're at all concerned about mycotoxins. Put it in a paper bag, put it in something cold, keep it away from heat, and yeah, you can spread it out on a kitchen table and get it to dry, you know, but don't keep it in a plastic bag. Anything else? Yeah.
I got a question for you. Has anybody done any work with micronutrient sprays instead of a fungicide, like say copper, zinc, silicone?
No, we've done copper, just like copper sulfate,
Yeah.
and
No effect.
no,
Okay.
no, unfortunately not. Anything else? So my advice to you, if you don't already have a program in the Maritimes, like you got to do it. You know, it takes a bit of a volume effort so that you can afford to do it. But I would take the varieties thing very seriously, and don't let any stinkers in. You know, get them out. If you've got some that you know, so get a testing program together, publicly funded or whatever. And so that's what we have every year. We have our cereal crops committee, and we have these trials, and then we report 4 or 5 years of data. I saw that you have something like that. I looked online, but it was only 1 year data, and that's just a crapshoot. and it didn't look like it was inoculated, and it didn't look like it was misted. That has really helped us a lot. And so you keep a stinker in there so you have a check, but you don't grow those stinkers. You know, they can hurt you really bad. And we've had lots of luck in the cereals, mainly wheat, of doing that. When we had 96, I got everybody together and we sat around a table. We got the millers, we got the elevators, we got the growers, the seed companies, the province, everybody sat around the table. She said, we can't let this happen again. And what do we got to do? And then we did it, we stuck to it, and we made a huge improvement. So we had a real big problem in 2018 in corn. Like, it was bad. The other previous really bad one was 1986, the year before I started. So my program was kind of tailored to the Fusarium question, starting in corn. I tried to get everybody in 2018 together. Nobody was interested. Hybrids are big business, and nobody wants anybody to tell them that their hybrids are no good. And so we haven't progressed much in corn at all. Anyway, I see I'm done. All right.